Assalamualaikum warahmatullahi wabarakatuh. We are from Group 7 and our group name is Binsu. And my name is Luqman Hakim Rahmat. And now I'm going to present question 1 for this assignment. So first is even function. The function that I'm using for this question is 2x plus 2 and 3. The period for this function is 4 and L for this function is equal to 2. Since this is even function, this function Bn for this function is equal to 0. So as you can see, this is how the graph for this function. So after that, I find the a0 for this function using the equation 1 over L integrate fx dx. And then I got the answer for the a0 is negative 4x plus 2. And then I find the an for this function using 1 over L integrate fx cos and pi x over L dx. And then I got the answer for an is 8 over n pi square cos n pi. So I find the an using tubular method. And then the final answer for this function is a naught, which is negative 4x plus 2 over 2 plus an. So next, for the odd function, I'm using the function x multiplied by x minus 4 and negative x multiplied by x plus 4, where fx is equal to fx plus 8. So the period for this equation is equal to 8 and L for this function is equal to 4. Since fx is an odd function, a not equal to an equal to 0. So I find the n for this function using the equation 1 over L integrate fx sine and pi x over L dx. So the answer for Bn I got is negative 16 over n pi power of 3. And I find the Bn using tubular method. And then the final answer for this question is Bn only. So next, I'm going to present the neither even or odd function. The function that I'm using for this question is x plus 2 multiplied by 2 minus x and negative 3, where fx is equal to f x plus 5. So the period for this function is 5 and L for this function is 2.5 or 5 over 2. So first, I find the a0 for this function using the equation 1 over L integrate fx dx. And I got a0 is negative 6 over 5. And then I find the an for this function using equation 1 over L integrate fx cos and pi x over L dx. And then I using the tubular method. And then I got the answer for en. Next, I find the Bn using the formula 1 over L integrate fx sine and pi x over L dx. And then for Bn also, I use the tubular method. And I got the answer for the Bn like shown above. So the final answer for this function is a0 plus an plus Bn. So that's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Faiz and I'm here to talk about task 2 for MAT 565. Uh, First, this is my function which is x plus 6 and this is the function for period which is x plus 8. Okay. For cosine series, the expansion will be function will be rotate 90 degree at y-axis, thus create an even function. For this, this is the general function for half range of cosine series function. Okay, first we must find its length L, which is P equal to 2L, and P is equal to 8. So you use basic math and you will get L equal to 4. For N naught, we just substitute the L that we got earlier into this equation. Okay, then we will got this. Just substitute and all, and then we got A naught, which is A naught is equal to uh, A naught is equal to 16. For AN, just use this formula and we substitute the L equal to 4. And this is what we got. Because we have two function here, we need to use the tabular method. Okay. First, the tabular method. For differentiation part, we take the first function, which is x plus 6. And for integrate part, we take cos n pi x over 4. Okay, let's continue. I think this is where we left from before, which is Bn for uh, cosine series is 0. So after we got An, then we just substitute all, and this is our final answer. Okay, for sine series, uh, which is function, we still use the same function, which is x plus 6, and still the function will be rotate 180 degree at origin, which create an odd function because of the diagonally symmetry. And we just substitute all in L into the Bn equation, and here we have, but for this calculation we have two function in one same integration. That's why we need to use tabular method. For differentiation part, we use x plus 6, and for integration we use sine over n pi x over 4. Here is what we got: 34 over n pi minus 40 over n pi cos n pi. And this is our final answer for Fourier sine series. Okay, then another function is added to expand the function, which is fx equal to 3 from range 0 to 6. Since there is no symmetrical y-axis and diagonally symmetrical at origin, the function are neither even nor odd. This is our graph. This is for x plus 6, and this is function of f(x), f function of x, uh, which is 3. Okay, for Fourier series, since it is not even nor odd, we have to find all. This is the general equation for Fourier series, which is a naught over 2 plus summation of an cos n pi x over l plus bn sine n pi over x sine pi x over l. A naught equal to 6. Okay, for an is still the same, and we still have two function. This. So an we got this 6 over n pi square multiply with cos n pi plus 1. So and we combine it all, we got this. Bn equal to negative 6 over n pi plus 3 over n pi multiply with 1 plus cos n pi. And we must substitute all into the original function, which is this, the general, and this is our final answer. Okay, thank you.
Assalamualaikum and hi. My name is Muhammad Amir Akmal bin Muhammad Nasir. Matrix number is 2022815844 and I'm from Team Bingsu, which will be presenting for task 3, which is the harmonic analysis question. For task 3, I need to find the Fourier series expansion up to the third harmonic. All calculations must be correct to 3 decimal places. For x0, the angle varies from 0 to 330 with addition of 30 degrees each, and for y, I put some random numbers for the sake of the question. And because it says to the third harmonic, which means n equals to 3. And for the solutions, I will be using all these formulas in order to get the answer. And here, and here are the tables that I've made in order which is the calculations for all the things I need for the questions. And as you can see, the part that we actually really need is the bottom part, which is the summation for all the things on top. And here are some calculations example. For example, r equals to 2. If we need to find y2 cos 2x2, we simply put y2 is 2.41 cos 2 times 30 degrees, which we will get 2.41 cos 60 degrees, which is 1.205. And for the Fourier series in standard harmonic form, here are the equations that we need, or the components that we need to find the answer. And for a0, which is 1/6 times the summation of f xr, I put 1/6 times 34.92, which is 5.82, and we will and we can get c0, which is 1/2 times a0, which is 2.910. And for a1, we just simply put the formulas all there, as you can see here. And for c1, we need to calculate square root of a1 square plus b1 square, which is equals to square root of negative 0.178 squared plus negative 1.464 square, which we get 1.475. And lastly, we can calculate the angle, which is a1, which is alpha 1, equals to tangent inverse a1 over b1. And we put the numbers there, and there we got and as you can see, alpha is equals to tangent inverse y over x. If y is negative and x equals to negative, we simply see that it is the location is on the third quadrant, which we will get a positive number, 6.932. For the angles, if the value is positive in quadrant 3, we want the angle equals to 180 plus the angle that we get just now. And here is the answer, 186.932 degrees. And we can simply solve the others just like we get for the n equals to 1 components, just like that. And you can see the angles there is y is positive and x is negative, so the position will be on the second quadrant. And here are the rules for the angles, which we will get alpha 2 equals to 180 minus 80.373. And for a3 and for the n equals to 3 components, we can simply just calculate them and we get the same thing. And for the alpha 3, we can see that the y is negative and x is negative, so we will get the third quadrant. Yeah, just repeat all of that and there we are. And we can get the equation, which is the Fourier series expansion. Fx equals to c0 plus c1 sine x plus alpha 1 plus c2 sine 2x plus alpha 2 and plus c3 sine 3x plus alpha 3 plus and so on. And that is the final answer for the questions. And here are my calculations that I've made in order to get the answer and to present the video. And that is all for me. Thank you.